Hello everybody and welcome to episode 5 of Remaking Cavestory in C++. This episode is called Animating Our Sprites. I am Limeoats, my website is limeoats.com, my Twitter is @limeoats. This is my GitHub link, it's where all the source code is located. And this is my subreddit where all of these videos and more is posted, so definitely check out that. Alright, so as the title suggests, today we are animating our sprites. So what's the problem we're looking to solve? We need to animate our sprites, and more specifically, for right now, Quote. Quote is our main character. If you remember from last time, our sprites aren't really doing anything on the screen. They're just kind of sitting there. I'll run this really quickly so you can see what I mean. So here's where we left off. As you can see, Quote is just standing still, not really doing anything. So in this episode, we're going to get him to run around a little bit. Not move his position just yet, but he'll be running in place by the end of this episode. So that's what we're going to do. And the code we're running today applies to all sprites, so not just Quote. So we'll be using this code for a very long time. Alright, so some details. There's only one thing really. Quote's running animation has 3 frames each. And when I say each, I mean 3 frames per direction he's running. So let me open up in paint.net really quickly our sprite sheet. Where did I put it? Data. Oh, actually, I don't need to put data from there. I can get it from right here because we already added it to the project. So sprites, mychar.png. It'll open up in here, but that's good enough. If I zoom in on this, notice how he has, when he's facing left, he has 3 frames here where he's running. So we're going to use all 3 of those for running. When he's facing right, he also has 3. These are when he's looking up and running, so we'll get to that later. We're not going to deal with those yet. But for right now, we're going to focus on these 3 frames in our sprite sheet. So that's the running animation. Let me close out of this now. So there are 3 frames. That's going to be important when we start implementing this. So what are we doing? What do we have to do to accomplish this? First thing we need to do, we have to fix the global width variable. I put a smiley face here. For some reason, when I was writing this code last episode, I messed up the width of the window, so we're just going to fix that. Not a big deal. We're going to create a global vector2 struct. A vector2, I like to call it a vector2 because that's what it's called in some other libraries, and SDL doesn't have anything like this. It just makes it easier to deal with pairs of information like x and y coordinates or widths and heights and stuff. So we're going to create a struct just to handle that. Then we're going to create the AnimatedSprite class, which extends off of our existing sprite class. So all animated sprites are sprites, obviously. So we'll create that. And then we're going to use the animated sprite in the game class instead of using the sprite class like we are right now, since Quote is an animated sprite and not just a regular sprite. And then we're going to watch Quote run endlessly when we run it. Like I said, he'll be running in place for right now. Okay, so let's get started. The first thing, we're going to fix our global width variable. So to do that, we are going to go into globals.h and see I have 600 here. It's actually supposed to be 640. That's the correct resolution. I said that In an earlier episode, we used 640, and when I was writing this global variable, I put 600 for some reason. So that's it. That's the first thing. We're moving along well here. That's done. Next up, we're going to create a global vector2 struct. So back in globals.h, down here underneath our namespace, we're going to put struct vector2. Alright, and then it's going to have two member variables of this structure. There's going to be an int x and an int y. Notice how I'm not putting public or private here. Structures are by default public. The members are automatically public. And I want them to be public in this case so we can access them very easily. So we're going to leave it public like that. And then the constructor for vector2 is just going to initialize x and y to 0, like that. But more importantly, we're going to have a, well, that was the default constructor. This is going to be our constructor that we're going to be using most of the time. It's going to take an int x and an int y, and then we just do this to initialize x and y to whatever we pass in. And then I'm going to make a quick helper function here called vector2. It's called 0. And all this is going to do is it's going to return a new vector2 initialized to 0, 0. This is the same as the constructor, but it'll make more sense to call 0 than just to call an empty default constructor here. So whenever we need to do this, we'll just use this function. And that's it. So that is our vector2 structure. We're going to use that in our animated sprite, which is actually the very next thing we have to do. So let us go into, we're going to make a new header file. So go into our header folder. It's going to be AnimatedSprite.h. So if not defined AnimatedSprite h, define AnimatedSprite h, end it. Alright. So let's start. We're going to forward declare graphics right from the start because we're going to be using that. I know that already. So we're just going to forward declare it. Then I'll put a comment here for our AnimatedSprite class because I like to do that. Holds logic for animating sprites. Pretty obvious, but it's nice to know. So class AnimatedSprite, now it's going to publicly inherit from our sprite class. So we need to include, right around here, sprite.h, so that we can inherit off our sprite class. So the first thing I'm going to do is make a constructor. That'll be our default constructor. We're probably not going to implement it right now, but we're going to need to have it there or we'll get warnings later. So then our other constructor is going to take our graphics object. It's going to take a file path to our sprite sheet. SourceX and SourceY, just like our sprite, we're going to be passing all of this into our sprite class actually. That's why we're taking it here. Our int width and our int height. A position x and a position y, again just like our sprite class. And then a new one called time to update. And what time to update is going to be how long until you're supposed to go on to the next frame in your animation. Okay. So next we're going to make a void play animation. And this is going to be an extremely important function because this is how we're actually going to start playing different animations, obviously. We're going to pass in the name of the animation. So the way this is going to work is we're going to be storing animations by name and a little bit more information about them. So to play one, all we need to do is pass in the name to this play animation function. And we're also going to have bool once equals false. Now, for those of you who don't know, this syntax here, this is called the default parameter. Default parameter? I think it's called default parameter. Optional parameter, that's probably a better name. You don't have to pass anything in here when you call play animation as a second parameter. You could just leave it blank and call it like play animation run, like this. You can technically do that and not pass anything in, or you could pass in a bool and it will work as well. So what that's going to be for is whether or not this animation should only play once or if it should loop. So void play animation and plays the animation provided if it's not already playing. So there will be logic in the play animation function to not do anything if it's already playing, so that it doesn't keep resetting. So yeah. Next is our regular update. So void update updates the animated sprite with a timer. We're going to have a timer that's going to keep track of when to move to the next frame in our animation. So we'll get to all of that. Of course, we have our void draw, which is going to take graphics as always, an int x and an int y as always. Now, this just draws the sprite to the screen. Okay, that's nothing new. We've always had that. Then I'm also going to have a virtual void setup animations. Now, the reason it's a virtual void is because we're not actually going to be implementing it here in the animated sprite. Well, eventually we're going to make it a pure virtual function because we're not going to be implementing it in AnimatedSprite. But for right now, we actually are going to until we create our player class, probably in the next episode. So we're going to have to implement it right here for this episode just so we can watch it work. So that's why it's not pure virtual yet, but eventually it will be. So what this function is going to do is it's just going to add a bunch of animations. It's required, that's why we made it virtual. In any class that is an animated sprite, you have to implement this, because if you don't, there will be no animations to go through. So we definitely need to set them up. A few private variables. I'm going to go up to the top and include a few more things. We need to include map, and we need to include string. We're going to be using both of those. And we got sprite, and that's good. Also, we're going to include globals because we're about to use our vector2 structure that we just created before. So a couple private variables. First thing is an STDmap. If you remember from, where did we use STDmaps? I believe we used it in our graphics class. Let me open that up. Yeah. This is to hold our sprite sheets. We did it in the graphics class. And it just takes in two things. In this case, we use a string and an SDL surface so that we can access SDL surfaces by their names, which is a string. We're going to be doing something very similar here. The first thing we're going to have in the map is a string. And then we're going to have a vector of SDLRect. Okay? And it's going to be called animations. So, what's the problem? The problem is that I also need to include vector. Yeah. Alright. So, what this means is we're going to have a map full of animations. This way we can keep track of all the animations that a sprite has. We're going to access them by the name of the animation, which is the string, which we're going to set up the name. We're going to give it a name in setup animations. And then the vector of rectangles is each of the different, let me open up this picture again. The vector of rectangles is, for example, for this one, our vector would be full of this rectangle, and this rectangle. So what that does for us is it lets us access the locations on the sprite sheet of each of our frames in our animation. So that's what we're going to keep track of for each animation. So it's just a vector of rectangles, a list of rectangles. So that's that. That's very important. That's where we hold all of our animations. We're also going to have an STDmap of string and our vector2 that we just created called offsets. Now, the reason for offsets is if in our sprite sheet we have maybe we're not exactly 16 pixels per animation, or per frame, I mean, or we just want to move where the sprite is being drawn, we'll give it an offset by however many pixels. Store it in here, and then we're going to add this when we actually draw our sprites. So you'll see the use for that later, but we need it for now. We're also going to have frame index, which is which frame in the animation we're at. We're going to have time elapsed, which is for our timer, and a bool visible, which is whether or not the animation is visible. And that's it. That is our AnimatedSprite class. So now all we need to do is implement this. So let's create a AnimatedSprite.cpp. We're going to include AnimatedSprite.h. We're going to include graphics.h. We already included vector, so now we can just put AnimatedSprite class animates our sprites. Alright, so our first thing we have is our default constructor, which we're not actually implementing right now, so we're just going to leave it alone. It's going to give me a warning. That's okay. The next thing is our real constructor, which takes graphics, file path, SourceX, SourceY, int width, int height, float pos x, float pos y, and float time to update. Alright, lots of parameters there. We're going to initialize all of our stuff now. Actually, hold on. I forgot. I'll finish this first. That's okay. We forgot some variables. We're going to have some protected variables as well. And I forgot to add those in AnimatedSprite.h, but we'll add those as soon as we finish this function. First thing we need to do is call our sprite constructor by just writing sprite and passing in graphics, file path, source x, source y, width, height, pos x, pos y. So that sprite will take care of a bunch of stuff. That sets everything up there. Frame index will set to 0 to start. Time to update, we're going to give time to update. Visible will start out as true. Now here we have two variables that I didn't write yet because I had to put them in the protected section, but we'll just write them in right now. Current animation once will start out as false, and current animation will just be an empty string like that. Okay. So what's the problem here? Oh, I need to include sprite. Typo, should have been a capital P. What else? Time to update. Did I not put that one either? Alright, that is another variable it's at. So go back to AnimatedSprite.h quickly. We have a bunch more stuff to add that I forgot to add. So underneath setup animations, put a protected, put the word protected like that. And a few variables. We'll have double time to update, which is the amount of time between frames. Bool current animation once. That's how we know whether or not an animation is only being played once. And a string current animation, which is the name of the current animation that's being played right now. Next, we'll have a function called addAnimation. This is how we actually add animations to our list of animations for a sprite. So we'll just be calling this function a bunch in our setup animations function to set everything up. So this will take int frames, which is the number of frames in the animation, an int x and an int y, which is where on the sprite sheet the animation starts. A string name, which is what we're naming the animation, an int width and an int height, which is the width and height of each of our frames, and a vector2 offset, which I explained before why we need that. So our comment for this, add animation, adds an animation to the map of animations for the sprite. Alright. So that adds an animation. Next we have reset animations, which just clears out the map of animations. So resets all animations associated with this sprite. A couple more. We have stop animation, which obviously just stops the current animation. Oops. We have set visible, which changes the visibility of the animated sprite. And then we have one more called virtual void animation done. This is going to take a string, the name of the current animation, And what this does is it's logic that happens when an animation ends. So this whatever we implement here, it's required. Whatever we implement here will happen every time an animation ends. Now this is the end of our AnimatedSprite.h. So now if we go back in here, all these functions exist and everything is happy. I mean, all these variables exist. So now we just have a bunch of implementing to do. It's not too complicated, so let's just jump right into it. The first one we're going to implement is add animation. So this took a bunch of parameters. Okay. So what we need to do is we need to basically cut up our animation, our sprite sheet, I mean, into the correct number of frames, and store those rectangles in our map. So we're going to make a temporary variable here. It's going to be a vector of rectangles. And this is just where we're temporarily going to hold on to each of our new rectangles that we're going to put into our map. So we're going to have a for loop. We're going to loop through our sprite sheet, the number of frames that it's being passed in. And we're just going to create rectangles out of our width and our height and everything. So a new rectangle equals, we can initialize rectangles with like this with the brackets. So our x position, which is the first thing an STLRect wants, is going to be I plus x times width. So let's look at this quickly. I'm again going to open up this picture and zoom in pretty far. So I plus x times width. So when I create my animation, I'm going to say for this running left animation, I'm going to say that there are 3 frames, the x is 0 and the y is 0. So what this is going to do, what the code here is going to do, is it's going to say, all right, 3 frames. So the first time around, I is 0. We want to grab, the first time around the for loop, we're grabbing this. 16 by 16. So first time around the loop, I is 0. So 0 plus 0 times 16 is 0. So we'll start out right here as our x, and that's good. Our y is just going to be whatever we're passing in as y. And then our width and our height. Like that. So that when we want to grab this one, I will be 1. So it's going to say 1 plus 0, which is what I just passed in as x, because that was the starting point of all this. So that's 1 times our width, which is 16. We'll put our x right here, right where the second one starts. Y is still 0 at that point, so it works. And it'll grab this perfectly. And then when I is 2, it'll be 2 plus 0 times 16, which is 32, which will put us right here and grab the third one. Happens 3 times, it'll grab all 3, and we have our animation stored in this vector of rectangles. So, well, it's not stored yet. I need to, every time around that loop, push back new rect, like that. So now after this loop ends, we have all of our animation, all of our frames stored in this rectangle vector. So now we have to add it to our map. So to add something to a map, we're going to use the insert function. So animations.insert. And we need an STD pair. Since we have to add 2 things. We have to add the name and the vector of rectangles, we're using pair to pair them together. So the pair is of type string and of type vector of STLRect. And what we're passing into that pair is the name that we passed into the function and our vector of rectangles called rectangles. That'll add it to our map. And then we're also going to store our offsets that we pass in. Same exact thing, std pair, only this time it's a string and a vector 2, just like our map for offsets. And we're going to pass in name and offset. So now we'll be able to get the offset by the name of the animation, and also the frames, the rectangles, by the name of the animation. Okay. And that's our add animation. So that's how we cut up our sprite sheet and get everything. Next function to implement is AnimatedSprite reset animation. So for this, all we need to do, maps have a really nice function called clear, which just clears out everything in the map. Just like that. So this should be animation. And that's it. So that clears out both of our maps for animations and offsets. Next up, we have a very important function called play animation that takes in the name of the animation and whether or not we're using it once. We don't have to put the equals false here because that's already in the header file. So here, the first thing we're going to do is we're going to set current animation once equal to whatever we're passing in as once. Then we're going to check if the animation we're trying to play now is already playing. So we're going to check if current animation does not equal animation. Then we need to start playing this new one. So set current animation equal to animation and restart frame index so that it'll start at 0 at the beginning of our animation. And that's it. That's how we play animations. This all becomes important in the update function where we're actually where we have our timer and everything. Next is set visible. Just sets visible equal to visible. Very basic. Next we have stop animation. So this is how we stop an animation. We set frame index equal to 0 and we call animation done on the current animation. Then we have our update. So this is where we're going to have a timer going. Oh my, I don't know why I can't type AnimatedSprite today. This is where we have a timer going that's going to be checking when to go to the next frame in the animation. So the very first thing we're going to do is we're going to call sprites update. Since we're extending off of it, we can call it like this. Then we're going to start our timer. So time elapsed. Well, we're not starting the timer here. This is going to be happening every frame. So we're just adding on to the timer, saying that some time passed, and then we're going to check if it's time to update. So if time elapsed is greater than time to update, that means we need to change frames. So now we have to decide which frame to go to. So the problem here is if we're on the last frame, we need to go back to the first frame. So it's not as simple as saying, well, if you're on frame 0, go to frame 1, go to the next frame, I should say. If you're on frame 1, go to frame 2, etc. Because you need to check if you're on the last frame, then go back to the first one. So we're going to check that now with if frame index is less than animations at current animation dot size minus 1. So size will always be 1 more than the index. Since frame index starts at 0, size starts at 1. So we have to check minus 1 when comparing with frame index. So what this pretty much says is if frame index is not at the last one in the animation, then simply increment frame index by 1. However, if you are on the last one, if current animation once equals true, then that means, okay, we hit the last frame, our whole animation is played one time, we have to stop. So we're going to just set it to invisible right now by calling setVisible so that we don't see it. And then we're going to set frame index equal to 0, no matter what. So this sets it back to the beginning, since we were on the last one this past frame. And then we're going to call animation done current animation because the animation finished one time. And that's it. So that's how we increase our frame index and change where in the animation we are based on this timer. So next up is our AnimatedSprite draw function. This takes graphics, X, and Y. This isn't much different from our sprites draw function. So if it's visible, we only want to draw it if it's visible, obviously. Then we create our temporary destination rectangle, which is where on the screen we're drawing, and we set it up. So destination rectangle.x equals x plus, now this is where offsets come in. We're going to add whatever we set for offsets x to where we're drawing, and that'll just push it over by whatever we set for our offset when we draw it. Doesn't actually change the position of it, but it will be drawn in a different position with the offset, and that's what we want. Same thing for Y. And then for width and height, we're just going to use SourceRect .w times our global's sprite scale. And our SourceRect is still in Sprite, so that's where we're getting it from. Same thing for height, except we use SourceRect.h. Okay. Then we get a SourceRect based on our animation map. So we're going to create a new SDL-rect here called SourceRect equals, and we're going to pull out some information. So we're going to pull out the rectangle that we're drawing this frame from our animations map. So we're going to get it by our current animation string and by our frame index. and that will pull out the correct rectangle. So this indexes the map to get the vector, the correct vector for our animation, and then this indexes the vector to get the correct rectangle from the vector itself. So that's why we have two of those there. And then our good old graphics.blitz surface, passing in the sprite sheet, SourceRect, and the destination rectangle. Good. Next, we have AnimatedSprite animation done. So this is what happens when our animation is done. We're not going to put anything in there yet. So we'll just move around to the final one, which is setup animations. Now, this is not going to be implemented in this class after this episode. It's going to be implemented in everything that's inheriting off of AnimatedSprite in the future. But for right now, unfortunately, we don't have time to make the player class right now. So I'm just going to implement it here, and then we'll move it out of here later. So for this function, all we're going to do is call add animation. So we need to give it some information. So for our, let me open this up again. For our running left animation, we have 3 frames. So for the number of frames here, I'll give it 3. For X, we're going to start, the entire animation starts up here at 0. So I'm going to give it 0. For Y, the entire animation starts up here at 0 too. Then we need a name, so I'll call it run left. The width is 16 pixels, the height is 16 pixels, and no offset. So I'll give it an empty vector. And that's it. That's how you use setup animation and add animation. Okay. So now, what does this do for us? Well, what this does for us, we don't have to change Sprite, I don't think. So even though we're inheriting off of it and doing some different things here, we don't need to change it. So the next thing in our notes, now that we implemented AnimatedSprite, is to use it in the game class instead of Sprite. So let's first go to game.h. Up here, instead of including Sprite, we're going to include AnimatedSprite. We're going to change the type of player from Sprite to AnimatedSprite player. Okay. Then go on into sprite.cpp, and not sprite.cpp, I'm sorry, game.cpp here. Okay. And what we're going to do here is down here where we initialize our player, where we were initializing with the sprite constructor. Now we're going to do it with the AnimatedSprite constructor. And we have to add a parameter here to the end called time to update. So I was playing around with it, and a good time to update is 100. Now you could slow it down or speed it up by changing this number, but I think it looks about right at 100 for right now, so we'll leave it there. Then we need to call 2 more of our AnimatedSprite functions. Since now players in AnimatedSprite, we're going to call setup animations to add in those animations. And we're going to call play animation to set up our first animation for when the player starts, called run left, which we already created. And then our draw stays the same. All we need to do now is change update. So we're going to call player.update, passing it elapsed time, and this will call our animated sprites update to change the animation. So I'm going to build, see what happens. Alright, we have build errors. Let's see what the problems are. Sprite sheet is a private member of Sprite. Alright, so what that means is we need to go back to sprite.h and change a couple things. See how SourceRect and Sprite sheet are both private right now? We're using them in AnimatedSprite, so we need to make them protected instead. So all we're going to do is write the protected keyword up there and move these up to protected. We can keep X and Y as private for right now. So I'm going to build again, and it looks like it was successful. Alright, that's good. That was fast. Alright, nice to see everything build after all that with no problems. So now I'm going to run it and see what happens. Yep, save everything. And there he goes, but he's running really fast. That's interesting. I don't know why he's running so fast. Let me look around. We can first look in AnimatedSprite. Well, first actually, we're initializing it with a 100 time to update. Let's try making that 300. That should slow it down, and let's see what happens. And it's not. So what that tells me is that it's not that. There's something else wrong. Let's look at our animated sprites update. Alright. That's pretty funny. If we're moving to the next frame, we have to subtract from time elapsed time to update. Yeah. Alright, I missed that line. Everything should work now, hopefully. There we go. So as you can see, that was a silly mistake. I forgot a line. As you can see, quote is now running around on the screen. Not running around, running in place. Yeah, that looks good. Now, a fun little thing we can do really quickly, actually. I didn't plan for this, but let's try it. We can change which animation is happening. We'll make him run to the right now instead. So let's change play animation to run right. And let's go back into AnimatedSprite.cpp down here and set up animations. We'll leave run left, because that's fine. We can have multiple in our map. We're going to add another one. Now it's 3 frames. So to run to the right, the X is still 0 over here. Still starts at 0, so 0. Now the Y is different though. The Y is going to be 16 because it's 16 pixels down from the top. The width and height are still 16 and still no offset. So we can leave run left in there. That's perfectly fine. Oh, we got to name it. Whoops. Run right. And this is how we set up our animations. We'll just keep on adding more and more animations as we need them. So let's run it and see if he's running to the right. And he is. So that's his run right animation. And you can just switch them now by going into game.cpp and changing which animation is happening. Run left will again make him run to the left, and so on and so forth. So the next step is going to be, let me go back into our notes over here. Let's talk a bit about next time. I like to talk about next time at the end of each episode so that we know what's in store, what we need to think about and work on. It's time to make quote actually move around on the screen. So the next step is changing quote's direction, and so setting up more animations like I just showed you how to do. To accomplish this, we're going to make a player class, and that will hold all information about our player. It's going to extend off of AnimatedSprite, and it will be great. We'll have movement, we'll have direction. So that's where we're going to leave off for now. Again, my website is limeoats.com and my Twitter is @limeoats. Please follow. If you have questions, you can tweet at me. I will always answer them. It's the best way to contact me. All this code will be on GitHub under the episode 5 release, and Reddit. My subreddit, this video will be posted there right away, and all future episodes will be posted there as soon as they go up. So it would be great to subscribe there, and so you find out about everything. And you can ask questions there as well. Good place for discussion. And of course, please subscribe to this YouTube channel so you get updates as soon as I upload videos. So yeah, thank you very much for watching, and I will see